Okay guys, in this video we're going to talk about the next part of inverse matrix, which is on how to inverse 3 by 3 or higher matrix by using elementary row operation known as ERO. Just by its name, we know that this methods will be calculated, right? Will be performed based on the row operation. So everything will be changed by row. So what is it actually? Okay, so we have these two metric. First is the metric called A, and then we also have identity metric, right, which is in the same order. So both be n time n matrices. So it can be 3 by 3 with 3 by 3, 4 by 4 with 4 by 4, as long as they are the same, right? Because to solve using elementary row operation, we are going to combine A with identity, right, to put it in this form. I'll show you later how what will the form be, and it is called augmented matrix. So first it will be in the form of AI, so in the form of A on the left hand side and identity matrix on the right hand side. And by conducting elementary row operation, we are going to change it into this A here. We are going to change it in the form of identity. So from a matrix with numbers, we are going to change it into identity with 1 at the diagonal elements and 0 at other elements. Okay, so when we successfully change A here into identity, automatically the in identity metric here will also change into other value, so which is called the inverse of A. So basically we are going to change from AI augmented matrix of A identity into identity inverse. Okay, so in order to do that, we are going to manipulate a bit, right, on the value inside the matrix to change it into 1 and 0. Okay, so to change, there will be certain rule that we'll need to follow later. So this is the characteristic that we are going to need to abide in conducting ERO. So let us first check. Okay, the thing that can be done later is to interchange between rows. So we can change between the rows, and we can also multiply our rows with any non-zero scalar, any constant, any numbers, and we can also add and subtract between rows. Okay, those are the things that can be conducted in ERO. Okay, and then what is this about? Let's A be a square matrix of order n. Okay, this I've already discussed about this before, but what's more important is, if possible, row reduce A to identity using ERO on the entire matrix. The result will be I and A inverse, as I said before. If this is not possible, A is not invertible. So basically there's also a tendency that our matrix is can't be inverse. So as I said before, to avoid that, right, it is actually a good practice to see the determinant first of each of your matrix. Make sure that it is not equal to 0, so we know that it is invertible. Alright, so let's try to do this one. Okay, before we proceed, why don't we check whether this is invertible or not? Okay, or maybe if you can just try to do this one. Okay, so both of this is actually invertible because that's why they have the answer, but why don't we just try to do it? Okay, so the first step is to check whether A here is invertible or not, which is by looking at the determinant. Alright, so this is the determinant, and it is not equal to 0, so it is invertible. So we can proceed. with the ERO. Now let's look at how to conduct ERO. Let me set up the augmented metric first. Alright, this is the augmented metric where you have A on the left hand side. A on the left hand side and the identity metric on the right hand side. Because of the A is in 3x3 form, the identity metric should also be in 3x3 form. Okay, now how do we calculate ERO? Right? By you need to we need to actually use the available calculation that is allowed in ERO. So as I said before, the first kind of thing available to be made in this ERO method is to interchange between the row. We can change one with 2, one with 3. We can just change between the rows, not the column, the rows. Okay, and we can also multiply, alright, the columns with any value, any numbers, right, any scalar, except 0. And we can also subtract or sum between the rows. That is the amount of operation that can be done in ERO. So let's see. So the target will be to change all of this into identity metric. So basically this should be 1 and all of this upper triangular should be 0 and all of the lower triangular should also be 0. Hence it become identity. So how do we actually do that? So we need to calculate one by one. So usually we are going to start with the upper left hand side, which is we are going to change it into 1. After that we are going to change all of the value below it into 0. Then we are going to move to the next column. We are going to change this into 1, and then we are going to change the top and bottom of it into 0. Next we are going to change the last column, right, the bottom part here, into 1, and then we're going to change all of the value above to 0. That should be the sequence, the best sequence, I think, because if you are going to change it randomly, it will later affect what you have changed before. So to make sure that you are not do things twice, right, after change it back, we need to follow a certain sequence. So that will be the sequence that I suggest, which is to start from the top left and end at actually the top right. So find 1 here, and then find 0, and then find 1 in the middle, and find 0 at the top and bottom, and lastly find 1 at the bottom, and finally 0 at these two elements. Hence it will become the identity metric. We know that it can be changed because we all know that it is invertible, right? Unless that this is 0, then it is not inversible. Okay, so how to change? The question is what operation that we can do to change this into 1. Okay, so we know that we can multiply the row, right, by any value. So why not we just multiply this -1 with another -1 to make it 1. Okay, so basically we are going to just multiply -1 R1. So we indicate that -1 will be multiplied with all R1. So when we say all, you start from this point until the end. All of them will be included. Okay, so what you need to do after that is, you cannot really copy just like what I did here using computer, but what you can do is you can copy the value that is actually needed to be calculated here. So what involved here is R1. So just copy R1 first, leave the other blank, solve for R1 first. So we know that -1, so everything will become positive, right? Negative times negative, positive. So this one become positive. You all times all element in row 1 into -1. So this one become negative and 0, right? don't become it don't really affect it here. Okay, so we have solved this one. It will become 1. So how to change? Now we don't need to look at this one. We look at the recent one, which is this one. How to change all of this to how to change this one to 0. So we can we know that we have 1 here, so we can multiply this with 4, and later we can subtract R2 here with 4. So basically we are going to just do like this. We are going to subtract R2 sorry, with R1 that has been multiplied by 4. So later will be 4 minus 4, 0, right? So 4 R1. Okay, so 4 R1. Right, so okay, let me just do it from scratch. Right, alright, so this is what I meant before. First, just create your next matrix and substitute and just copy the rows that actually involved in this calculation. Now we have row 2 and row 1. Just do that first. Okay, so R2 minus 4 R1. So we have 4 minus 1 times 4. So 4 times 4 is equal 0. Right, 0. 5 times 5 minus 4. Sorry, minus 5 minus 4 is equal to 1. 0 minus 4. To get here negative 4. Okay, after you have get everything, just copy the other columns that is actually not involved. 1 0 1 3. Then we have 0 0 1. Right. So we have already solved up until this point. We have 1 0 0. So now automatically we also have 1 here. So what's next we need to figure out is how to make this to become 0. So obviously we can subtract R1 with R2. Right, let's do that. Alright, so this is what we get after we subtract R1 minus R2. So we have able to obtain 0 here. Next, we need to make this to become 0. So the same way, just that R3 minus R2, so that we can get this 0. Let's do that. So that's it for this one. Right, we have already get this 0. Now we still have the last column to be solved, so that at the end it can become identity. So let's solve for this one first. How to make 0 become 1? So simply multiply with 1 over 7. So we become 7 over 7, then means 1. Okay, so let's do that. Alright, now 2 more to go. Let's change these 2 into 0. How to change 5 into 0? So we are going to subtract R1 with R3 that being multiplied by 5. So that 5 minus 5, 0. Okay, so R1 minus 5 R3 will give us this. So we already have almost all of them equal to the identity. This one, we only need to change this one, negative 4 to 0. So negative 4 minus negative 4 plus with 4R3. There you have it. Now we have changed all of them into identity matrix, and by changing this, we also need to calculate the initially identity matrix on the right hand side, and from this it has changed into this. So this is the matrix inverse for A, right? Thank you.